Hi, this is Geofield Sonja Philipp from Germany, talking about geothermal energy for a second time. 2 weeks ago, I told you a little bit about why there is geothermal energy, and today I will focus on geothermal energy use and what are the advantages and drawbacks, what are the difficulties, what are the geological preconditions that are needed to use geothermal energy. Well, there are several forms of geothermal energy that can be used. There is surface near geothermal energy that is partly at least is really solar energy, where you need only very short boreholes or even only some facilities below the garden, for example, to use the groundwater. And there are also deep geothermal reservoirs. That means they are more than 1 or 2 kilometers deep, and where there is direct use of the heat from the rocks through the geothermal water that is flowing there. And the classical facility is the so-called geothermal doublet. That means a system of 2 boreholes. Through one borehole there is cold water pumped into the system, and from another borehole there is hot water taken out. The rock is used as a heat exchanger, so the water flows through the rock, and that is mainly through fractures. Because the main parameter that is needed for geothermal usage is permeability, rock permeability. That means the ease of how easily water is flowing through the rock, and that is mainly through fractures. Of course, we need hot water. We need a certain temperature for electricity production. There is typically steam needed. That means we need 100 degrees Celsius or more. There are some facilities also that are able to use lower temperatures that need use, for example, organic fluids, not water, as for steam production. The high temperature is, well, when we are in a volcanic area, is usually not really the problem. And in other areas, such as Germany, for example, higher temperature means just, drilling deeper. So that is, of course, a question of costs, but the main problem in most cases is really the rock permeability that needs to be reached. And that means that we need to know the permeability of the rock, or at least make a certain estimate, because the drill holes, the wells, are very expensive. That's quickly in the order of million euros or dollars. And so it's better to ask a geoscientist before drilling. It's much cheaper to have a good geological and geophysical exploration campaign, even if it costs some money, of course. The main geophysical method to look in the subsurface is the so-called seismics. That gives a good picture of the subsurface and makes structures visible. Fault zones are commonly visible or can be interpreted in seismic sections. It is, however, it is not really possible to see the individual fractures that are needed. So fault zones are often very good structures, particularly when they are in a geologically in an orientation that is in the current stress field. It is possible that the faults would also be active. But the small-scale fractures we are not able to see in the seismics or with other geophysical methods. We can use data, of course, from existing boreholes in the vicinity, but we cannot see directly the fractures that are in the subsurface of the reservoir when we want to use that. One possibility is to use data also from outcrops. So from outcrop analogs, that means we have rocks of similar age and facies, and we can look at how they react to fractures, to fracturing. That does not necessarily mean that we use the exact number of fractures, the fracture frequencies from the surface, but we gain understanding from the 3D view of an outcrop to interpret the fracture systems that we can find at depth, and that we can use for example, for computer models for simulations of fluid flow in the subsurface. So it's good to combine knowledge from geophysics and structural geology, that is my expertise, and hydrogeology, for example, to get a picture of the subsurface reservoir before drilling. One problem, of course, is when we are in fault zones, we can induce seismicity. It's well known that pumping fluids into an active fault zone that is used during stimulation or so-called fracking of the reservoir can induce earthquakes that are being felt by people, so in the order of several magnitudes even. That can be a very difficult problem. It is, however, it is not technically possible to induce an earthquake that is not naturally possible at a certain location. So when there is no large-scale fault zone, we will not have an earthquake of magnitude 7, 8, or 9. But still, also an earthquake of magnitude 3 point something can be a major disaster for a geothermal reservoir, not because it really destroys anything, but as soon as this is felt by people, it will be difficult to convince people that all is fine. And there are several geothermal projects that were given up after some induced seismicity problems. So the advantages of geothermal energy are that it is not only possible in volcanic areas, but in many places it is possible to have permeable rocks or induce some permeability or increase at least permeability in rocks. So it is possible in very many places, almost everywhere, and it is relatively cheap, so it is worth really using. It can be, there is no seasonal or change, so it's usable in the winter and the summer, when the sun is shining, when the sun is not shining, or when there is wind or anything. So there is no real variations. When we have set up the power plant, it can be used almost every day and night. There is very little afterwork needed. And it is also, on almost any location, so it makes independent of energy from other states, like when there are some political problems or so, it's good to be independent in a country. Yes, but if there is, of course, it's depending on the local geology, and a good exploration campaign is needed before drilling. I can only make the case that geologists are needed for that, and geophysicists as well, because the drilling is very expensive, and one needs to have good expertise, reliable data on the subsurface before drilling. And of course, we are cooling down the reservoir, and that means that we cannot use a geothermal power plant infinitely. That means after a certain period of time, commonly in the order of 30 years, one needs to wait until the energy has been regained. So there is a heat flow from below. I talked about this 2 weeks ago, that heats up the reservoir again. So theoretically, one can just wait maybe 100 years and use the same reservoir again, or use the same rock layer a few kilometers away. Fault zones are often helpful, but also critical. So fault zone does not necessarily mean everything is permeable. There can also be impermeable fault zones, fault zones that are rather barriers to fluid flow. So that also makes the case for geological exploration before drilling. Yeah, if there are any questions, please ask them. I see that there is one, in fact. What type of well boring do they use to find this subsurface information? Do you mean well boring? Do you mean geophysical logs in the wellbore, maybe? So there is, for example, there is VP measurements, so that's seismic velocities that give information about mechanical rock properties, or there is the natural gamma rays that give information if there is clay minerals or sandstone, for example, or the gamma gives information about the rock density, and when there are permeable layers, there can also be fluid flow into the wellbore, or you can lose the mud, the drilling mud into the rock formation that gives indication on that there is a permeable layer, to find out what types of rock layers. Yeah, that's so that I spoke about the geophysical well logs that give information about the rock layers. Okay. Well, there's also hello from Haris, and well, yes, there are. It's difficult to talk about the whole system in a few minutes, but there is a lot of information that we use. Of course, we use not only seismics, but there can also be gravimetric measurements, for example, or magnetic measurements that give information about subsurface plutonic rocks, for example. Important is also to use data from previous boreholes. So when there are boreholes in the vicinity, we can use pumping tests. How much water was it possible to extract from a borehole, not only in a short experiment, but experiments of many days, for example, where there are maybe also tracers put into the water that can be analyzed again, so that give more information about the quality of the reservoir, or also what is it called? Borehole imaging, that gives information about the fractures that can be seen in a way in the borehole wall, and can be analyzed. And so it's good to have data from existing boreholes, but one well must be the first one. So there you have to go with geophysical data and geological studies, use the geological map and existing expertise to extrapolate from the surface, or to have an educated guess about the depth. How about the fault geology structure in geothermal system do have affected impact for water migration? Yeah, well, we are, for circulation, we use the water circulation through the fault zone. So it is, for example, it's possible to use a system of two wells where you have one, both within the fault zone, and the water is running parallel to the fault plane. And so we induce a fluid circulation, or we use a natural fluid circulation. So it's very common to use the circulating water. Otherwise, I don't really understand the question if you mean anything else. It can, of course, also be a problem when you want to drink this water as well. Yeah, it's the surface water that is used for drinking is maybe not the best goal or target to use for geothermal energy production. But the deep water is usually not drinkable anyway, so there is too much mineral content, and that rather gives some problems that these minerals precipitate in the wells or in the power plant system. So it's often needed that the water is kept under certain pressure, and it's not the direct steam of the water that is the geothermal water, but you use steam from clean water and just heat this with the geothermal water. So you need a heat exchanger where the geothermal water is running by some clean water that is changed into steam then. Yes, I think that was the last direct question. If there are any more questions, just post them in the comments. I will try to come back to them later. Thanks for watching and have a nice day. Bye.